welcome my fervent physics students. Once again, we're back at the physics, and this time we're going to look at the idea of momentum. So momentum is simply actually an expression of force in regards to mass and velocity. So if you have an object, let's say we've got a ball, right? And that ball is moving, let's say at 3 meters per second squared. And I give you the option of getting hit by this ball that weighs 10 kilograms or this ball that weighs 0.05 kilograms. Which one are you going to choose? Well, you'll say, oh, well, of course, I'm going to choose this little ball right here, right? Because this little ball right here isn't going to hurt, even though they're traveling the same speed. Why not? The force is going to be a lot less with this little ball because what hits you is momentum. There's not just speed, there's also mass. So momentum that we symbolize with the letter P in physics equals mass times velocity. So now let's go back to our classic equation, which is the force equals mass times acceleration, Newton's second law. Everything fits into this, and so we want to see where we can find momentum in here. Obviously, mass and velocity are in here. We know that. So let's go ahead and pull this apart and find this. So we have our mass here, and we know that acceleration equals the change in velocity over the change in time. So if we look at change in velocity, actually let's just go ahead and take change in time over to this side. So we have force times change in time equals the mass times the change in velocity. So change in velocity is going to be the velocity final, and that is going to be, not times, sorry about that. So we have mass times, we could break this up into velocity final and velocity initial, right? And so then we could distribute the mass out. So this could be minus the mass times the velocity initial. So mass times velocity we know as P. So another way of writing this is the momentum final minus the momentum initial. Then we also have this over here because this equals the change in momentum. The force times the change in time is going to equal the change in momentum. So basically, a force applied over a certain amount of time will change a mass's velocity and therefore change that momentum for that mass. And so this right here actually has a name as well. This is called an impulse. So an impulse is defined as a force distributed over time, or a Newton's second, right? Newtons times seconds, whereas mass is going to be defined as kilograms times meters per second. So that's going to be the unit for momentum. All right, so let's look at a few quick little examples right here of how we would solve and look at the idea of momentum in physics. So I've gone ahead and I've drawn a little example here. Let's see, we've got a car that's 725 kilograms, and let's see, say it's moving to the east at 115 kilometers per hour. So the question is, what is the car's momentum? And so this is pretty simple. So we think about the fact, though, that when we're looking at momentum, we have to convert that to meters per second. So let's go ahead and do that right off the bat. So we have 115 kilometers per hour. Okay, I want to convert those kilometers to meters. So I'm going to say that there's 1,000 of those in one of those. And I want to convert those hours to seconds. So I'm going to say that one of those hours is 3,600 seconds. All right. So if I multiply this by 1,000 and divide by 3,600, I'll find out that this equals 31.94 meters per second. All right. Now that I have it in meters per second, I can look back at my momentum equation, which says that momentum equals the mass times the velocity. So I know the mass to be 725 kilograms. So if I go ahead and just plug that in, 725 kilograms times my meters per second, which is 31.94 meters per second, I'll come out with momentum of 2.32 times 10 to the fourth, and its momentum, so this is kilograms times meters per second, and this is going to be in the east direction. Since this car is traveling in the east direction, we're going to have to make sure to specify that. You always want to do that because momentum is also a vector measurement, and so with vector measurements it's really important that you include direction. If it tells you it's going east, you're going to want to make sure that you show that it is still going east. Alright, let's look at one more little problem right here. We'll go ahead and get rid of that one, and let's go ahead and do this one right here. So here I have a situation of a cylinder. Let's say we got a cylinder that's 7 kilograms, and it's rolling along a flat surface. Okay, so it's rolling along a flat surface at 2 meters per second. And so then what's going to happen is I have this force over time graph situation that's going to show me 3 different scenarios. I got a pink, I've got an orange, and I've got a green scenario. And these are impulses, right? Because I have force and time. Okay? So I have a force applied over a certain amount of time. So all of these are impulses. So a force-time graph is going to be your impulse graph. Now, in order to figure out the impulse, it's quite easy. All you have to do is look at the force and multiply it times the time. So if we look at the pink one to begin with, the pink one right here, our impulse is simply going to be our force times our change in time. Sorry about that, little triangle wasn't very good. Is going to equal, in this case, we have a force of 5, and that spans for 1 second. So 5 times 1 is going to equal an impulse of 5. Okay, so pretty simple. Let's go ahead and then look at the other ones. Let's go ahead and look at this orange one right here. We have an impulse of -10. So this is a force in the opposite direction to which this one is moving. So we have -10 applied over 2 seconds. So -10 times 2 is going to give us an impulse here of, I'm going to go ahead and just write that, -20. And it's going to be Newton seconds. And we already said that this one is 5, right? Now, what about this green one right here? The green one is a triangle indicating that the force wasn't constant at 10. It sort of gradually worked up to 10 and then gradually worked itself back down to 0, and that spanned 2 seconds. So if you have a force-time graph, really what you want to look at is the area of the force-time graph actually equals the impulse, because impulse is force times time. So all I got to do is calculate the area. So here we are. We have the area of a triangle is going to be 1/2 base times height. So my base is 2, and my height is 10. All right. So this impulse here is going to equal 10 Newton seconds. All right. Let's go ahead and see what this would do to my cylinder. Now my cylinder is moving at 2 meters per second, and it is 7 kilograms. And we know that momentum equals mass times velocity. So my momentum for my cylinder to start with is 2 times 7. So my momentum initial equals 14, right, kilograms times meters per second. Okay, so that's my momentum initial. Now I know that my impulse, which is force times the change in time, equals my momentum final minus my momentum initial. So I could just simply plug any of these in. Let's go with the green one right here. We figured out that that was 10. So that impulse right there was 10 Newton seconds because it was 1/2 10 times 2. And so that is going to equal my momentum final minus 14, because that's my momentum initial. So let's go ahead and break this up even further then, because I know that momentum final is going to equal mass times velocity final minus 14. I know what the mass is, so the mass in this case is 7 kilograms times my velocity final minus 14. Okay, so what do I have here? Well, I'm just going to go ahead and add 14 to this side. So I end up with 24 equals 7 times my velocity final. Divide both sides by 7, and I find out that my velocity final is what is my velocity final? Go ahead and calculate it. Okay, it's going to be 3.4 meters per second. So this particular impulse right here with the green is going to cause my spinning cylinder, my rolling cylinder, to increase its velocity to 3.4 meters per second. So that's the idea of forces applied over time, momentum, mass, velocity, and kind of how they relate together. Hope that helps with solving some of your physics problems in the next few days. Stay tuned for more examples and more momentum ideas and how things are going to work out if they collide.